This conference will now be recorded.
Hi everyone, welcome to the next class on Introduction to Wireless and Data Communication Networks. So today the topic which we are going to discuss is about wireless LANs. But before we go ahead into today's topic, let us just try to recollect that we have learned in our previous session. In our previous class, we were talking about a topic called the two models of network and the various types of addressing used in the network. So the two network models that we have discussed was OSI model and TCP/IP model. OSI model is a layered model architecture. It's an open system interconnection, and the different layers are used to perform different functions. And to interconnect two layers in the model, we have interfaces, and we expect a peer-to-peer communication happening between the two peer layers. Okay, so to define or to understand the communication between the devices, a set of rules and procedures were used, which were referred as protocols. So here you could look at the figure, which is indicating about the different layers we have, and the interfaces that we have between them, and also we could find. So we have the different layers, then we have the interfaces connecting the layers, the two adjacent layers called as peers, and to connect the different devices, we have been using intermediate nodes like routers or switches. And each layer of OSI model is being defined with certain set of functions that we have gone through in our previous session. We just refer to one of the slide which gives you a summary of different layers and their functions performed in the OSI layer, right? Okay, so this is the summary of the different layers of our OSI model. Let us start with the first layer called physical layer. This is basically responsible for transmission of bits or the transmission medium. It selects what type of transmission media to be used. It converts the data received from data link layer into bits of zeros and ones, which are later transmitted as either optical signals or electromagnetic signals, depending on the transmission medium used. The physical layer is also responsible for the type of topology to be used, right? Then coming to the data link layer, this layer is basically responsible for receiving the data from the network layer, and then it converts the data into the frames. Along with this, it also performs the roles like node-to-node delivery. For instance, in the previous case, between the source and destination, we had some intermediate nodes. Now the data link layer is responsible from source to intermediate node 1, or intermediate node 1 to intermediate node 2, and then node 1 to node 2 to destination. So that kind of delivery will be referred as node to node delivery. And coming to the third layer called network layer is responsible for routing of data from source to destination. It is responsible for generating an address called IP address. So it's like the MAC address is generated by this data link layer, right, which is responsible for node to node delivery. And here the network layer is responsible for end-to-end delivery, right? So our network layer, we have internet protocol, which is one of the important protocols supported by different other protocols. Okay, so majorly it is used for routing and process to process delivery. And coming to the transport layer, the major function is not just end-to-end delivery, but we need a process to process delivery that is taken care by transport layer. Besides this, it is also helping us in error detection and correction, which may be happening at the higher layer from compared with data link layer. It receives the data from the session layer and converts it into segments. And here, the transport layer uses an address called port address, which is used for process-to-process delivery. Next one, which we have in the series, is called session layer, which is basically used to establish, manage, and terminate the sessions. When it has what to be sent, when to be sent, and how is to be sent will be decided by the session layer. session will actually initiate the sessions, and the presentation layer above the session layer will actually do this job of what to be sent, how to be sent. So it takes care of the functions like encrypting, compressing, and translating the data. But the final and the topmost layer called application layer is actually the one which is actually accessing the resources and generating the data. This is in brief about the 7 layers of OSI model and their functions. So the alternate model to understand the networks is called as transmission control protocol and internet protocol layer. If OSI model focus on functions of layers and the interfaces and the protocols, here the TCP/IP is majorly focusing on protocol sets. Let us just have a quick glimpse on TCP/IP model and the different set of protocols we use before we go for the next. So the TCP/IP model, we have different set of protocols, and instead of 7 layer as in of OSI, we have simple 4 to 5 models, 5 layer model. The first one is application, and here the presentation session is combined into application layer. Then we have transport, then we have networking layer, and here data link and physical is together referred as underlying network layers. Okay, sometimes in some books the physical and data link layer are referred separately, and we will have the 5 layers. And what are the most important protocols that are used at different layers is what we focus in TCP/IP. Coming to the network layer, we have important protocol called internet protocol, which is supported by protocols like ARP and RARP. Same time we have IGMP and ICMP. So these are the protocols in your network layer. Coming to the transport layer, majorly we have two important protocols. One for the connection oriented, for which we use TCP. If it is a connectionless unreliable, we go for UDP. But if you want to combine the features of both, we are going to use SAID. And the major applications which are actually generating the data is the one which you are occupied in the application layer. Now, if it is related to the mail, we use a protocol called simple mail transfer protocol. If it is related with attaching a file or downloading a file, it is related with file transfer protocol. If you are trying to browse or to connect to the internet system, we are using hypertext transfer protocol. The domain name or the website address which we type to get to a particular website or a server, we refer it as domain name service. And similarly, for managing of network, we have simple network management protocol. And when you are trying to make a remote login, we use a protocol called telnet. So these are different set of protocols we have in application layer, and we'll try to understand the functioning of each of this in our unit number 4 and 5. Okay. So there is a small comparison between the TCP/IP and the OSI models, and we'll try to look at it sometime in the later. Okay. So now this is what and last thing that we'll discuss before we go to our next class is about different types of addressings that we use in the different layers of OSI model. So coming to the, as discussed in the previous slides, if we are referring about data link layer, the type of address referred is called as physical address. It is responsible for node-to-node delivery. If you are the type of address you are referring is for end-to-end delivery, the address is called IP address, and it is referred and related with the network layer. If it is for process-to-process delivery, then we are referring an address called port address. And if you are referring for a particular domain or a website to reach a particular server, that we have been referring it as a specific address. So these are the different addresses associated with TCP/IP. Okay, right. These are the things that we have discussed in our previous class, and I have small examples related with how TCP and IP and OSM model are related and their differences. And next video about different types of addresses. Fine. I hope these are the things that we have discussed in the last class, and hope you will recollect things which are important. And the remaining topics are completely dealt with these concepts. That is the reason why we are trying to recollect the things. Okay. With this, shall we move to the today's topic called as wireless LANs. So this is the last topic of our unit 1. So let us have a quick glimpse on wireless LANs. Right. So what are the things that we are going to discuss in our wireless LANs? Let us have a quick glimpse. So here we are going to talk about what are the different elements of wireless LAN. Then we are going to discuss about the different characteristics of wireless networks. Then we try to understand one of the models in wireless networks called CDMA. And then we'll try to understand IEEE 802.11 wireless LAN, which is popularly known as Wi-Fi. And we'll try to understand the architecture of IEEE 802.11. Okay, so these are the things that we are going to discuss in this class, and I hope people will be understanding and closely related with what they use in the real-time scenario. Okay, let's start our discussion for today with what are the elements of wireless network. Right. First, let us have a quick look at how a wireless network appears. This is a simple a picture reflecting how a wireless network appears. Now, what you could find here is a set of devices like laptops, mobiles, trying to get connected. Then we have a kind of what we say, the antennas, which we refer it as base stations. Then we have a network infrastructure, which is trying to connect all these devices and the base stations. And then we have a link between them. Right. And what do you mean by these particular zones? And what does the blue color indicate? All that we'll try to discuss in our discussion. Okay. Right. So let's start our understanding of what are the different elements of wireless network. Now, as we said, the first thing we need to understand in the very important element in the wireless network is wireless host. What are wireless hosts? Right. It might be a simple mobile phone which you would like to connect to yourself. So this is my mobile, and this is a wireless host, and which is trying to send the data, and which is trying to receive the data. I'm trying to work on my laptop, so it's a wireless host. So wireless host means something which is trying to connect to a network without using physical wires. Now that doesn't, my laptop generally I'm trying to carry out, or my mobile phone, which has been can use while moving ahead. So they are mobile in nature. But I have something like a device, my TV, which I don't carry with me, but still it is connected to a network. So it's not mobile in nature, but it's a wireless and device because there is no wire connectivity between my TV to my Wi-Fi router. All right. So wireless host is something which will try to connect to the network without using wires, but it doesn't mean that all wireless hosts are mobile in nature. Okay. So I hope these points are clear. So this tries to connect to the network without use of wires. And then the examples of wireless hosts can be a laptop, smartphones, and they may be fixed, or that is called stationary, or they may be mobile in nature. Okay, clear? So this is how the various devices which you have been shown are indicating the wireless host. Okay, the next element in your wireless networks is the base stations which are trying to connect this wireless host to the network. Right, the ones which you could find here. Right, so a base station is the one which is actually trying to connect the various wireless hosts to the wireless network. Right, it acts like a controlling element. Now here, this is the one which you are indicated in the blue color is actually trying to make you understand this is the area covered by one particular base station. Right, got it here. So what is the role of base station is if someone is trying to send a packet to this device, so that base station will actually try to receive the data, try to identify this wireless host, whether that is a part of its network, and once it identifies, it will try to send the data to the concerned wireless host. At the same time, when a wireless host would try to send the data to someone, the wireless host need to be connected to the base station. Like you are trying to send some information on mobile phone, first you need to connect to the base station, which will be connected to the infrastructure, network infrastructure or wired networks, right? Okay, so the base station does both the jobs. It will transmit the data which is sent by you to the next end. It will receive the data from the other network and try to forward to you, right? So here the cell towers which have been indicated as base stations, and you can also refer them as access points. For this, first we try to understand what do you mean by wireless host, and then we are trying to understand now what do you mean by base station and what is its role. Okay. Now the third element in your wireless network is about the connection between the mobile device or the wireless host and base station. So the link between these two devices is referred as a wireless link. So this is typically used. So wireless link is typically used to connect mobiles to base station, right? It is also used as a backbone link, and it multiple access coordinates. For instance, in a network of mobile area, you could find multiple mobile devices are trying to connect to the base station to make a connection. So this kind will be controlled by the wireless links. So each of these wireless links will be having different transmission rates at different distances. So we'll have a look at that in the coming slides. Okay. So first, three things are key elements: a wireless host, a base station to connect to the in network infrastructure, and third in the link between the wireless host and the base station. Okay. I hope so far things are clear for us. Right. Let us move to the next slide. The first thing which we need to understand in elements is here you could find the two types of networks. The first case, in the first circle you find there is a base station which is actually trying to just a second. You find a base station which is actually trying to connect different wireless hosts to the wireless link, right? When you have a base station in your network to control this, it will be referred as infrastructure mode. So when you have a base station to control different devices, you will be referring it as an infrastructure mode. Now sometimes what happens is you are connected to one particular base station and you are in a mobile nature. So you are moving from one network to the other network. So what happens is as you try to move away from one base station, your signal strength slowly starts decline. Means your amount of signal you are receiving from one base station is decreasing. At the same time, when you are moving from one zone to the other zone, you are trying to get signal from the another base station which is having a higher signal strength compared to the previous. So here what is required is you need to have a shift of control of your mobile from the base station 1, which is indicated here. So you have to have a shift from base station 1 to shift over to base station 2 when you are moving from one segment to the other segment. So this transfer of control of a mobile and signal from one base station to the other base station, we are referring with a name called handoff. So this is also one of the very important definitions. I hope I've been clear with things so far. And let me just complete the last one in this elements, which is called ad hoc mode. Now, if you refer to the previous slide, here you could find in one of the case there are only devices which are connected and there are no base station which is actually controlling those devices. So when you have a particular segment where there is no base station to control, you don't have a base station to control and only the devices are connected, then the kind of network will be referred as ad hoc network. Okay, or ad hoc mode. So there are two types: infrastructure mode, where you have devices controlled by a base station, and second one an ad hoc mode, where you don't have any base station to control the devices. So all these five elements first starts with wireless host, then we talked about base station, then we talked about the link between the base station and wireless host, and now then we discussed about infrastructure mode, and last but not the least, ad hoc mode. All this together will be referred as elements of the wireless network. Right? I hope we are clear. Right. Thank you. Now, next thing that we would like to discuss after elements of wireless network is the classification of wireless networks. Here, we are trying to classify the infrastructure mode and the ad hoc mode into two types called single hop and multiple hop. What do you mean by a single hop is if you are very close to a base station, then you have a direct connectivity from your device to the base station. Then that kind of connectivity is referred as single hop infrastructure based. So you have base station and you are directly connected to the base station. Something like this. It's a mobile and base station. And if both of you are directly connected without any intermediate device, it's called infrastructure, single hop infrastructure. But instead of mobile 1, we have mobile 2, which is not able to reach to base station directly. So what it does, it tries to communicate with the help of mobile 2 to mobile 1, and mobile 1 will be trying it to connect to the base station. In that scenario, what we have to do is, so in that scenario, we'll be actually referring it as multi-hop receive infrastructure mode. Got this? Single hop base station is directly connected to the via wireless host, but when wireless host is very far from the base station, we are trying to connect it through an intermediate host that is called multi-hop infrastructure. In the case of ad hoc mode, we are trying to say that we don't have a base station to control, and the devices themselves will try to form up a network. Then who will be actually taking the role of an so let us go back to ad hoc mode once. Here there is no base station to control. Then what happens? For instance, we are having a router at your home and four devices are connected. Got it? So the router here will be acting as a base station to which all the devices are connected. Now all of a sudden the power supply has been lost and you do not get your power connection to the router, but still you want to use your device. So what happens here? The router is absent, but still you need to want a network. So one of the four devices which you are trying to use in your home, you can just make it as an source by making it or the controlling element just try to on its hotspot. Now the device not only accesses the internet, but it is also trying to provide the services to the other devices. So that case where you don't have a base station like a router, one of the devices itself acting as those both device and the base station mode. That kind of infrastructure is called ad hoc mode. Now here, if this hotspot we have been talking about, or in this case, if your the first device is acting as a controlling element, and second device is directly connected. This is called single hop. But if your third device would like to connect to one and they are not in the reach, what happens? It will be trying to connect to the second device. From second device it will be connected to the first device. Okay, so this kind of architecture will be referred as ad hoc mode, single hop and multi hop. Okay,
This conference will now be recorded.
So this is how we have been classifying the wireless networks into single hop infrastructure network, multiple hop infrastructure network, single hop ad hoc network, and multiple hop ad hoc network. Okay, ad hoc networks is also referred as no infrastructure networks, right? Okay. So once we have understood the elements, now let's extend the next topic called characteristics of selected wireless links. Now we are talking about different types of wireless networks, wireless links, and what are the characteristics of those selected wireless links. Here, in particular, we are going to mention about two important parameters called as data rate, means the rate at which the data is transmitted, and the amount of distance that is covered using a particular wireless link. Okay. Now I hope you people are very clear and know about thing called data rate. So the Mbps which we talk about, this is speed at which the amount of data that can be transmitted in a given time. All that refers to the data rate. Okay. If you look at our previous versions, the data rate was not much higher. 1G, 2G, and 3G, the data rate was maximum around 2 Mbps, and now we find 4G, we find an improvement in the data rate, and there have been different technologies associated with the so-called the wireless networks. All right. So we can talk about 2G where very low data rate of 0.56 or 56 kbps. Then in 2.5G we are getting about 384 kbps. Then we have 3G which was supporting up to 4 Mbps of data rate, and now 4G which can support us up to 11 Mbps. We find next higher versions much greater than in the recent we have 54 Mbps, and we talk about 5G, you'll be talking about those data rates of 450 Mbps to 1300 Mbps on the wireless links. Okay, at the same time, we would also like to talk about the distance covered by different wireless links. Right? For instance, you talk about a Bluetooth or an hotspot or a simple remote device. The distance that will be covered will be very short. It's maximum around 10 to 30 meters. And we talk about outdoor, how much distance that can be covered, like your car key, right? So when you try to operate, maybe you can operate from the first floor, but when it is from third or fourth floor, you cannot get it because that communication is restricted, right? Similarly, mid-range and long range. So there are different distances which are covered by different wireless links. So here we need to understand. So there are two important parameters related with wireless links. One is the data rate at which the data is transmitted. The second one is the distance covered by the wireless links. Might be an indoor device, maybe an outdoor with a limited distance, mid-range or very long range distances. Right? Okay. So these are the different technologies which you have. For instance, IS-95, Interim Standard 95, Code Division Multiple Access, Global System for Mobile Communications. In 2.5G, we had Universal Mobile Telecommunication Standards, Wideband CDMA, CDMA 2000. Then we had High-Speed Packet Delivery Access. All that schemes are now 4G LTE long-term evolution, and in the future, very soon we can get about our 2020. 2023, we will have our 5G implemented in India, which already started in few countries, right? So which will be definitely providing us a higher data rates, right? Okay. Once we are done with this slide, let's look at the other important characteristics which are related with wireless links. Now, I said you in one of the points during our discussion that when a wireless host is trying to move away from the base station, its signal strength which starts slowly decreasing. That we need to understand. Simple. If this is my base station and I'm a mobile device. Now this mobile, the amount of signal it is receiving, this is my mobile, the amount of signal I'm receiving while I'm at this point, and let me again take one more point. Now the mobile moved from this position to this position. So the amount of signal that I receive at this point is definitely higher than the amount of signal that I'm going to receive at this point. So as I move from the base station, the signal strength starts decreasing. That is one of the important characteristics. At the same time, in the wireless, I'm using at one particular set of frequency. Like if I'm talking about, I'm using an ISM band frequency, industry, scientific, and medical band, where any user can use without me having a license. At the same time, the same frequency will be used by other applications. So that definitely will be resulting in that results in a so-called interference that need to be taken care of. Just give me a second. This one different. This was just give me one minute. Okay, right. So this is about our second important parameter called interference. And third is multipath propagation. What does it mean? For instance, I have a source and destination which is separated by a distance, and I want to transmit it a signal from source to destination. Now, if my signal travels straight from source to destination, it's called a direct. At the same time, as a source, when I generate that signal, might have been moving to the different directions. In the different directions, we may have different objects to which that particular voice signal got reflected, and they again, after reflection or diffraction phenomenon, they may reach to the same destination at different times. So I'm going to receive a same signal in multiple versions. Okay, so this particular phenomenon,
This conference will now be recorded.
where the same version of signal is received by the destination in multiple different times, we refer it as multipath propagation. That is going to impact on the quality of signal received. Okay, and definitely this multipath propagation makes the communication more versatile, right? So few of the things that we have discussed were data rate, the distance a signal travels. Then we talked about decreased signal strength. Then we talked about interference from various sources. Now we talked about multipath propagation. The next important thing in our wireless links or characteristics is called signal to noise ratio. What do we mean by signal to noise ratio? And how does it impact? Now, in the terminology signal to noise, the numerator talks about the signal strength that a receiver is received from the base station or sender, and the noise refers to the noise that has been added to the signal during the transmission. Now, the signal strength is much higher, means the noise component is very much low compared with the signal strength, and you receive a better signal. But if the noise component is more than the signal, so SNR will be low, and definitely you will have more noise than the actual signal. So generally, even all the other scenarios are constant, it's better we have higher to signal to noise ratio. But what happens if I increase my signal at my transmission? So higher my signal strength, and what happens is my signal disperses in multiple directions, and now I get a chance of getting interfered with other signals who are transmitting at the same time. So that is how we need to take care of how much the signal to noise ratio, and at the same time how much signal strength with which we have to transmit. The signal strength of the transmitter refers to the power at which the transmitter is trying to send the signal. Okay. Now in wireless networks, we try to measure the total amount of bits of data transmitted and the number of bits that got error. The number of bits that got error during the transmission is referred with a terminology called bit error rate. So we have here a simple graph which is trying to indicate how the bit error phenomenon is affected with signal to noise ratio. Fine. So just look at it. In this curve, if your signal to noise ratio, initially we had signal to noise ratio were very much less than 10. It might be 0, 1, 1, 2, 2. So the amount of bit error rate at this particular points is high. Here it is 10 power minus 2 when your signal to noise ratio is around 1, which means out of every 100 bits, 1 bit got error. Now you take at this particular point when signal to noise ratio of this particular modulation scheme, then the amount of bit error rate was 10 power minus 7, which means only 1 out of 10 power 7 bits got error. So what we try to understand here is when other phenomena are constant, even as the signal to noise ratio increases, the bit error rate decreases. This is one case. Here we are talking about one particular modulation scheme called binary phase shift key. So you have a comparison with other phenomena, like trying to use different other modulations. So look at this case of a blue line and a red line which you could find. Here, for a BPSK, when the signal to noise ratio is 10, the BER is only 10 power minus 7. But for a QAM, with the same signal to noise ratio of 10, here the bit error rate is 10 power minus 1. Why was this happening is, here, though the signal to noise ratio is same for the two modulation techniques, but the total amount of data that has been transmitted here is 4 Mbps, whereas in the first case, which is of BPSK, total data transmit is only 1 Mbps, right? So the data rate, higher the data rate, higher the probability of bit error rate. So first we try to understand higher the signal to noise ratio, lower the bit error rate. Next thing, if signal to noise ratio is constant, higher the data rate, higher the bit error. That is what you need to be understand. Okay. So I hope people are there. Then signal to noise ratio may change with mobility. So it may be adapted physically, right? This is next important characteristic. After understanding things like multipath propagation, then we try to understand the data rate, we try to understand distance transmitted, then we try to understand interference from other sources and how the signal strength decreases when you move from base station and away from the base station. And next, how signal to noise ratio is affected, the BAR at the same time, how BAR is affected for different modulation schemes, right? Now, the next thing we like to talk in the characteristics is two interesting scenarios called hidden terminal problem and interference. Now look at this particular example which you could be seen on the screen. Here you have three devices called A, B and C. A is visible to B, C is visible to B, but A and C are not visible to each other. So when they are not visible to each other, they don't know whether the other device is communicating with the B or not. In this scenario, what happens is we will find both A and C trying to transmit a data at a time, and there is a possibility of interference. The problem here is A and C are not able to be viewed to each other, because of which you got this particular problem. Now, this kind of problem is referred as hidden terminal problem. Okay. So there is another scenario. which is called signal attenuation. Now here you could find at A and C, signal strength they transmitted is very good, and they try to transmit a signal. As we learned in one of the previous characteristics, as signal transmits from the source, there will be a decline in the signal strength. Here, the same scenario, A can hear to the B, at the same time C can hear to the B, and A and C cannot hear to each other. And the next thing is, we don't have obstacles like in the case of the hidden terminal problem, but here we are focusing on the signal strength declining with the distance. And you find at one particular point, both the signals from A and C will be trying to interfere with each other, and there is a loss of data. The first one was hidden terminal problem. Here the reason is decrease in the signal strength with the distance. Okay. Right. Now, we were discussing about wireless links, one of the important property called multiple access. There are different scenarios which are implementing multiple access. The first scenario was where you try to divide the time into different slots and try to send different users different slots. That is called time division multiple access. An example for a simple time division multiple access is your classroom. All the 60 students are available, but for a faculty, only 1 hour or 2 hours is given per day, right? Now the other case is your lab. What happens? The time slot is fixed, but here 30 students go to lab 1, 30 students go to lab 2. So we are not dividing the time, but we are dividing the total students into 2 units. Similarly, in frequency division, what we try to do is the time remains undivided, but frequency is divided into 2 units. For instance, I got 2 Mbps bandwidth. For user 1, I'll give 1 Mbps. For user 2, I'm going to give 1 Mbps. That is called frequency division multiple access. But in case of time division, I would say half an hour I give it for A with 2 Mbps, and remaining half an hour I will give to B. When A is getting 2 Mbps, B does not get any bandwidth. At the same time, when B is getting the bandwidth, A does not get. That is called time division multiple access. Time division multiple access, any frequency in a given time. Frequency division multiple access, anytime, only a given frequency. But some scenarios, what we require is we want any time, any frequency, which is not possible with the first two mechanisms. There we are going to adapt a mechanism called code division multiple access. In code division multiple access, any device can transmit at any frequency at any time. Okay, so here you could find, so everyone want to transmit at the same time, then would there be an interference, or how will we overcome the problem? So what we try to do is to avoid the interference, each individual device will be given a unique code. So the code is assigned to each device, and the data which has to be sent by each device has to be multiplied with the unique code and then need to be transmitted. And all the codes which we have been used are orthogonal to each other so that there will not be much interference. So what is going to happen here is we are going to take the original data, then that will be multiplied with a code called chipping sequence and then transmitted. This combination of data combined with this code or chipping sequence is called encoded signal. So data will be transmitted as encoded. At the receiver, we'll try to split back the chipping sequence from data so that we'll only receive data. That will be referred as decoding process. Got it? Data combined with a code transmitted as encoded signal. At the receiver, we try to separate back the data from the code, which is referred as decoding. Got it? Right. What happens with this particular scenario is we can try to transmit multiple users at a time without much interference. That is the advantage of CDMA compared with TDMA and FDMA. Right, let us try to understand this with a simple example. Now I have two devices trying to transmit data. The first device data is referred as D0 and the second data device is referred as D1, and both of them are given separate kind of codes. So look at it. I have data called D0 and D1, right? What is D0 here? D0 equal to 1 and data bit 1 is nothing but -1. And I got a code. Okay. So what happens? My code will have to be multiplied with my data. In D0, which is equal to 1, is multiplied with my code. Now, finally, if I am sending totally two slots, the first slot DI into CL, and second slot D1 into the code. Okay, so cumulatively the data will be D0 C plus D1 into C. Now just look at it. First we are trying to multiply 1 with this code and it will be as it is. In the second case D1 equal to -1, then that will be reflected as -1 -1 -1 -1 into -1 is +1, and then 1 into -1 is -1, again -1 into 1 -1 becomes +1. So this is the combined data, and this combined data is called encoded signal, which will be transmitted to the receiver. The combined data is transmitted to the receiver, and now we have the data what you could find at the transmission without an error. It is expected to receive at the receiver. Now we need to decode the signal. So whatever that combined signal we had, we need to separate the code from the data. So simple, whatever the chip sequence which you have used at this encoding side, try to divide this combined data which we have received at the receiver with the chipping sequence, and we will be able to get our data at that respect. So what we have transmitted, D0 equal to 1 and D1 equal to -1, that is what again we are going to receive at the receiver. Okay, so this is how code division multiplexers is going to work. First we have the data, then we have a chipping sequence. We try to implement the encoding process by multiplying the data with chipping sequence, and while for multiple slots we'll try to combine the data, transmit as an encoded signal, received at the receiver, and we'll do the reverse operation by dividing the combined signal with the chipping sequence, which is referred as decode. Okay, so once again the same example, but in here the problem is we may have interference. When you find two senders trying to send the data at a time, D0 is 1, D1 equal to -1. In second case, D02 is 1 and D1 is also plus. We try to combine 1 plus 1 and we will find this particular sum which has been generated. Okay, so this is called interference. This is one of the issues that we need to take care in. Channels hubs together transmissions by center 1 and 2 using same code center 1 and tries to recover. So there is a small problem generated in serial, that is interference between the devices. Got it? Next, the last topic of this particular session in the unit is IEEE 802.11 wireless LAN, which is in short is well known as Wi-Fi wireless fidelity. When it happened, What are the versions of wireless LANs? Let us look at it. The first version of IEEE 802.11 was developed with a version called A, supporting a data rate up to 802.11, B, and it is supporting us a data rate of 11 Mbps. But good thing is it operates at ISM band of 2.4 to 5 GHz unlicensed spectrum. So what is advantage is you does not need to pay anything and you get service. Okay. So and all the hosts here will be using the same chipping code. Okay. Now we have another version of IEEE 802.11 called as 802.11a. Here we are trying to operate at higher frequency range of 5 to 6 GHz. But what is the problem when you try to operate with higher frequencies? You may get higher data rate like up to 54 Mbps. The problem scenario is they will be only used for short distance and there will be a high amount of interference. So if you want data rate high for a short distance, go with 802.11a. If you want a lower data rate but for a better higher distance with less interference, you opt for B. No sir, I want to get both the features. I need high data rate at the same time a longer distance. Then we try to combine the features of A and B, which is referred as 802.11g. It is going to operate in the free unlicensed spectrum from 2.4 to 5 GHz, but here we are going to get the 54 Mbps. So it's combining the features of 802.11a and B. But our data rate requirement is trying to be increased day by day, which cannot be met by 802.11g. So we are going for the next version called 802.11n, which can support you up to 200 Mbps. And here we are using a scheme called carrier sense multiple access collision avoidance for multiplex. We'll talk about this in our unit number 2. Okay, we have both base station infrastructure version as well as ad hoc infrastructure-less versions in Wi-Fi model. Okay, so 802.11, which has been related with wireless fidelity of Wi-Fi, it's been generated with the different versions. The initial versions, the low data rate, we had 802.11b. If you are having a high data rate requirement with short distance, we were using 802.11a. But when you want to combine, we were using 802.11g. And the latest versions in 802.11 is 802.11n, which supports up to 200 Mbps of data rate. Okay. Right. Well, earlier we started our discussion of this particular topic with this particular diagram, right? So here you could find one particular base station trying to cover, or here we have taken a simple two ad hoc networks where there is no base station. Okay, so the amount of area covered by each will be basically referred as cluster or zone. Here, what we are trying to do is a group of devices which are connected themselves to form a small network, subnetwork. This is called a basic service set. The basic service set is a group of wireless hosts. If it is having an access point or a base station, it will be referred as infrastructure mode. If it does not have a base station or access point, it will be referred as ad hoc mode. For instance, here basic service set 1 and basic service 2 are two ad hoc modes and they want to connect to a larger internet. For this, we definitely need to use a connecting device like hub switch or router. Okay, so only single basic service set with a group of devices, a base station, the wireless links, that is called a basic service set. Two or more basic service trunks trying to connect to themselves and to the internet, we refer that type of architecture as extended service set. Okay, basic service set consists of wireless devices, base station access point or without access point, and wireless links. Connecting two or more basic service sets, we are going to refer it as extended service set. Okay, Now, how does a device will try to connect itself to a base station? Do we need certain process? For this, we'll try to understand the concept called channels and associations. When you are discussing about 802.11b, it is operating in the frequency range of 2.4 GHz to 2.485 GHz. So we have totally 85 megahertz which is available, and that is going to be divided in 11 channels which are shared among multiple devices. So we have a possibility of having an interference. Okay, for instance, I just switched on my phone and I want to connect myself to one of the base stations. So that is what we are referring as a terminology called how do you associate a mobile device or a wireless host with an access point. Once you switch on your phone, you will be trying to find out what are the nearest base stations and the signal strengths which are being associated with that, and what is its MAC address of that particular base stations. Once you have more than 2 or 3 base stations having different signal strengths, then based on the highest signal strength, you'll be opting for one of the particular base stations. At the same time, you may be trying to find out whether the signal which you're receiving is authenticated or not. Simple, when you're trying to use your Wi-Fi, at the same time you'll find nearest Wi-Fi connecting zones and which of it is actually providing the highest signal, which is authenticated or not. All this can be identified before we make ourselves connect to one particular Wi-Fi. Okay, so this process will be referred as association, and we are trying to make ourselves associated with the base station so that we get certain channels for communication of device. So here, the process of identifying the nearest base station and trying to connect themselves is called as scanning, which actually happens in two ways. The first one is called passive scanning, the other one is called active scanning. The difference is the passive scanning will be initiated by the base station, thus active scanning will be initiated by the mobile device. Now let us try to have a look at it. In passive scanning, you could find for every frequent duration beacon frames, which are nothing but the information about the ID and its MAC address will be shared by the base station from access points, and that will be received by the wireless host, and then it will try to send a request that I would like to connect to your device. So here a laptop has connection between BBS1 and BBS2, or it may either send a request to BBS1 or BBS2. That is called the association request. And once a base station access point receives that received, access point 1 has received it, then it will send the association response sent from the access point 1 to the fetch one. Now remember, here the initiation of discussion is done by access point. That will be referred as passive scanning. But in other case, when a mobile device starts making the communication initiation. So here we will have the probe request which is originated from host 1. And this request is received by both the base station access points. Then we will find a response generated from each of these two access points. Then this host will try to evaluate the two responses, and whichever it finds the best, it will try to find an association request. And this request is traveling from host H1 to the association request travels from host H1 to access point. And whenever an association request is received by the base station or the access point, it will respond to that request. Now, an initiation for a connection establishment called association is done by the base station. We call it as passive scanning. If it is done by mobile host, it is called active scan. Okay, this is how we'll try to make an association with the base station and the wireless host. I hope this is what we have for our discussion. First, we try to introduce you about what are the various elements like wireless host, base station, wireless links, infrastructure mode, ad hoc mode, And then the types of wireless network based as single hop infrastructure, multi-hop infrastructure. Then we talked about ad hoc no infrastructure, single hop and no infrastructure multi-hop. Then we try to understand the different characteristics of wireless links like data rate, distance traveled, bit error rate, signal to noise ratio, signal strength, decreasing of signal strength. Then we had a discussion on decreased signal strength, interference from the other sources, multi-path propagation, and then comparison of SNR with BER. And then we talked about two types of issues that can be raised called as hidden terminal problem and interference problem. If two devices which are being hidden from each other are creating interference, we call it as hidden terminal. Those are not hidden, but there will be a decline in the signal strength resulting in the interference. That is the second scenario. Then we talked about the multiple access protocol, which allows at any time, at any frequency using a chipping code. Okay, we are trying to encode the signal before we transmit. At the receiver, we are trying to reverse the process of decoding the signal. Then we talked about IEEE 802.11 wireless LAN, which is primarily called Wi-Fi. The two versions basically called 802.11a and B. Short distance high data rate, we refer it as A. Long distance short data rate or small data rate, B. And a combined features referred as G. The next advanced version is called N, and these are using CSMA CA protocol. Then we talked about basic service set. What does a basic service set components include? A base station, wireless host, and a wireless box. And if you're trying to connect more than one base station, basic service set, we refer it as extended service set. And your basic service set can be either ad hoc mode or infrastructure mode. Then we try to understand what do you mean by channels and how we are trying to make an association between the base station and the wireless host, right? So we are going to divide the total available frequency into smaller units called channels, and definitely that is required for making a communication. And to make the selection of a particular base station or association, the host should know service set identifier and the MAC address. Okay. So when it is the scanning for the connection between the base station and wireless host is initiated by a base station by sending the beacon frame, and then the wireless host sending a request and getting a response from the base station or access point. We call it as passive scanning. But if the request is started from the wireless host and received by the base station and confirmed, and then again the process of initiation happens, then it will be referred as passive scanning. So this is what all you people have to learn from unit number 1. We have an introduction about networks. What do you mean by data, communication, networks, types of connections, topologies. Then we try to understand the network models, the two different types of models, what are the addresses used. And then we try to discussion with wireless LANs, the characteristics, the elements. Then we talked about CDMA, and next we talked about active scanning and passive scanning, which is related with Wi-Fi 802.11. Hoping you people got the rest of the knowledge, and any queries we'll discuss next class. I request you people to just go through the entire contents. Any doubts, put it on paper, and we'll have a discussion in the next class before we start our next unit. Hope things are clear for us. Thank you.